Yeah. So in this video, I show how to linearize student marks, assuming some didn't perform so well and you have to push it up, but you don't want to add a general score across, so that people who did so well also don't cross the bar. So assuming we have an exam over 70 and the least score is say 10, and you want to push that to say 20, and the highest score being say 70, but you want to say reduce, that is over 70, you want to reduce that to say 66. Then you're going to use the normal mathematics equation y is equal to ms y is equal to ms plus c. So in this equation, the x values are the 10 producing 20 and 70 producing 66. The x values are the 10 and 70. The corresponding y values are 20 and 66 respectively. And doing that, we're going to have two equations. The first equation, we're going to have say 20 is equal to 10m plus c. The second will be 60. What is 66? Yes. 66 is equal to 70m plus c. This will be equation 1. Oh, sorry. And this will be equation 2. So we solve these two equations simultaneously, and simply subtracting equation 1 from equation 2, we're going to have 46 is equal to 60m, implying that m is equal to, let me put it up, m is equal to small m, but don't worry for it, m is equal to 66 over 60, which is equal to 0.77. I'll keep that, 0.77. Then when we substitute m into any of the equations, say the first equation, we're going to have 20 is equal to 10, 0.77 plus c. When we solve this as well, we're going to have c is equal to 20 minus 7.7, and finally we can have c to be equal to 12.13. so that is c, 12.13, and we have m to be 0.77. Then finally we put them into our equation, y is equal to ms plus c. So we have y is equal to, m is 0.77, then plus c, x, while c is 12.13. so this is our linearization equation. We have to use it wherever we want to use. We will again illustrate how this is applicable in Excel, and then we can do that. So these are some Excel scores. Examination over 70, but from 1 people scoring, the highest is say 70, then the least is 1, but we want to push people from say 10. The least score will be 20. We forget about those others, but those are 10, the least score will be 20, and those are 70 should score around 66. So from our linearized equation, we will have here equal to, we have y was equal to 0.77 times x, and this becomes our x plus 12.13. then we are good to go. So 1 now is 13.7. I just scroll down and to the last point, and we are having the last score to, yes, 66.2. So realize that since we were going to 66, at some point the scores remain the same. Say 53, students at 53 were pushed a bit up to 53.11, but those at 55 coming was reduced gradually until the 70 mark was around 66.2. Similarly, those beneath, let me go to the 10 and the 20, you can understand that easily. Yes, those as 10 were pushed to 20, 9 pushed to something like 19.12, just like that. 11 to, just so the scores has been linearized enough. This is not adding across board. Then another thing we could do again is that since these are decimal points, we might have to have them in integer values by running them to the nearest whole number, each of them to, so 13 will move to 14, 14 move to 15, this move to 16, just like that. So what I do is, I want to put that in this next row for us to see. I'll use the round up. We can use a round down, but let's use a round up so that the student is not disadvantaged. Let me claim that equal to round up into bracket, the same thing that we did. The number could be this number, but let me use the original function to help us. So we have 0.77 times this plus 12.13. Then the number of decimal point is 0 at the end. Then I add brackets to that and I have enter. So 13 moves to 14. Then let me drag. You see, let me get to the end and we appreciate that. Excellent. So 62 moves to 66 moves to 67 powerfully, and these scores that we see here has been linearized so that students, those just far below, could just come up a bit, and those down, those, if those up there, maybe it was 50, we are pushing, that one could also be possible. This is usually not the case. We don't reduce student marks, but this another illustration to show a linearization of students' scores. So thank you so much for listening.